Hello, everybody. Good morning, good afternoon. We're just kicking off the webinar here. We'll wait 30 seconds till we get to the top of the hour and dive into things, but just open this up so we can start letting people jump on. Great. Well, welcome, everybody. Excited to have you here today. Mike Penrod from Wyebot, head of marketing, and it's going to be a good crowd. We've got 110 people with people still coming in and just at the top of the hour, 577 registrants in total. So a new record at Wyebot and a really interesting topic, which I think is what drew a lot of people to join us today. So we wanted to thank the WLAN Pros community and CWNP for their support of these educational series, for promoting it to the communities. And also just wanted to note that this session is eligible for continuing ed with your CWNP certs. So if you have questions about that, you can put it in the chat or send it to me afterwards and we can help you with that. Just a few housekeeping items. Slides recordings will be emailed to all the registrants afterwards, or will be available in the detail section of the YouTube recording, where we'll be posting this. And for anybody who's watching this live, there's a Q&A panel on the Zoom console here, where we will have engineers on the back end. Jacob, raise your hand, but yeah, Jacob will be on the back end helping to answer questions there. So feel free to ask any questions in the Q&A panel, and we'll get to those and share those answers with the rest of the group here today. So Wyebot's perspective, we look at this as just an educational series for customers and to support the Wi-Fi community. We have hundreds of customers that are dealing with Wi-Fi every day. We're in the weeds with Wi-Fi and just really like to share what we've learned and see if we can be of help to anybody who's in the Wi-Fi space. We're excited for today's topic because, like I said, Wi-Fi it's what we eat, what we sleep, what we breathe. Just a quick 30-second intro to Wyebot before we dive into things so you have context into why WPA3 matters to us. Our platform includes sensors and agents that are monitoring Wi-Fi 24/7 from the end user's perspective. This fills a crucial gap in monitoring and troubleshooting, giving details and insights into intermittent issues and details that just can't be seen from the AP or the controller's perspective. So some of the high-level features include synthetic testing, access to rolling history of PCAPs, RF analysis, and proactive identification of potential issues, along with recommendations on how to fix them. So just finally, just wanted to share Wyebot is used by organizations of all sizes, from one of the world's largest auto manufacturers. They're using Wyebot to monitor their IoT device connectivity on the factory floor, to a Fortune 500 enterprise that's deploying over 1,000 of our sensors across their offices to provide assurance for employee connectivity, to hundreds of educational institutions with sensors deployed throughout their campuses. So we love Wi-Fi. And with that, I'd like to introduce one person who is expert at that, Brad Howell, who will be presenting today's session. He's seen a lot. He's got 39 years in tech and 25 years of that in Wi-Fi specifically, including 17 years as an engineer at AT&T Labs. So we're really happy to have him on the team, really happy to have him presenting to us today. So Brad, we will hand it off to you.
Well, sounds great. And thanks everybody for joining this morning. Certainly great introduction. I appreciate that, Mike. From my perspective, it really is, a community. And if I had any advice to give anyone is just surround yourself with people that are smarter than you. I go by the Psalms or the Proverbs. He who walks with wise men will be wise. Surround yourself with those type of people. As we go through this session, we might decide that I may need a little more exercise. So we'll just see how that works out here. But the goal really of this particular webinar is really increase awareness. As we talk about WPA3, there may be some hesitancy from folks, right? It's like, it's too hard to go to. A lot of things to come into play on this. And again, the goal here is let's increase the awareness of where the industry is with WPA3. Give you some visibility into what others are seeing, and actually try to simplify things a little bit in this particular webinar. So that's kind of the goal for today. The agenda, we are actually going to have a poll sent to y'all for y'all to fill out online here. because we want to kind of get your sentiment and kind of get some insights around where you are in regards to deploying WPA3. Then from there, we'll start off, we'll go through some foundational terms and principles that we just need to know as we kind of go through really more of the fun stuff, right? We're going to spend a lot of time with PCAPs. If that's what you're in here for, I know we've had other webinars and we always get the comments of, we want more PCAPs. So we're going to be doing that. And we'll be looking at that with WPA2. We'll be looking at kind of an overview there because we really need to know what's going on or what has gone on with WPA2 to kind of understand the importance of having WPA3. So we will go through that. We'll go through some WPA3 functionality, what's new with WPA3. And again, we'll be diving into some the actual beacons and some transactions around WPA3. Enhanced Open, it's kind of grouped in with kind of the suite of WPA3. So we will talk about that a little bit. And then we'll kind of dive in at the very end towards Wi-Fi 7. We will look at a couple of PCAPs from Wi-Fi 7. Why is a Wi-Fi 7 kind of even up in the ante in regards to WPA3? And then, hey, we'll just kind of throw maybe a single slide about WPA4, right? We're still trying to get WPA3 deployed, but WPA4 is going to be needed, and we'll talk about that. And then finally, we'll kind of wrap it up around the standpoint of how Wyebot can help you in regards to evaluating WPA3, how WPA3 is working in your environment as you choose to deploy that. So that's kind of the agenda. So right now we got the poll up. Let's kind of spend a little bit of time here for you guys to fill that out for us. And then Mike, I think you may go ahead and give us the results of that after we have that. But let's give ourselves 20, 30 seconds. Everybody fill out those poll questions. And of course they are, how many have transition mode enabled? Does your organization have, have you been able to basically get rid of WPA2 in many respects? And then of course, maybe we just have kind of a segregated network, WPA2 in one network, one SSID, one VLAN, WPA3 in the other. So again, if you would go ahead and fill out the poll there.
Okay, Brad, the answers are slowing down, so we'll go ahead and end it here in 5 seconds and
Okay.
show the results.
Sounds good.
Pretty good sample size. We got about 160 people who have filled it out so far.
Awesome.
Okay, last 3 seconds and we'll shut it down. Great. Can you see the results there, Brad?
Sure can. All right. So we have, does your organization have WPA2, WPA3 transition mode enabled SSIDs? The answer is 37% of y'all say you do, 53% say no, and 10% are unsure. That's always an interesting response there. So hopefully we'll be able to narrow that down as well. Does your organization have WPA3 only enabled SSIDs? And we are seeing that as 33% yes, 61% no. And the last question was, have you eliminated WPA2 from your organization? And the answer there is 6% have been able to say yes. So what I'm seeing here with these results are kind of in line with what we're seeing out there in the industry. The slide I have showing on our screen is we basically went in and looked at the configured SSIDs for our Wyebot customers. And what we are seeing here is, first of all, the larger category is we've got 92% of our customers have WPA2 enabled SSIDs. 8% have WPA3 SSIDs configured. If you break that out by the different modes of WPA2 and WPA3, you can see there's 70% of our customers have WPA2 personal SSIDs configured. 22% enterprise, and then WPA3 personal 6 and WPA3 enterprise 2. So very interesting dynamic. Our customers are not home users, right, in general. So it's always interesting to see how prominent WPA2 personal is still out there in the enterprise type segments. All right, so with that, we'll jump to the next slide. So I borrowed this from just a recent WLPC presentation by Wes Purvis of Juniper Mist. And again, he is showing you what is the take rate essentially of where WPA3 is. Now, in this regard, we're seeing the big numbers, right? WPA2 personal 50%. So that's kind of in line with what we see with our customers. WPA2 enterprise 36%. Again, pretty much in line. WPA3, what's interesting is they're seeing 9% on the enterprise side, 1% WPA3 on the personal side. So OWE is also kind of that other category. So we do see a very small percentage on that as well. So again, what we're seeing is WPA3 is not really taken hold as of yet. Now, this slide here, maybe a little bit mitigating factor around what Juniper has in regards to where WPA3 personal exists across their customer base. But what's interesting here is if they have personal transition mode enabled, they're seeing that 80% of the clients into 2021 were actually connecting at WPA3. So the transition mode allows both types of connections, but if it's a WPA3 client, they are connecting. And that percentage has gone, really all the way almost to, you could say, all clients that are WPA3 capable do connect at WPA3. So interesting highlights there and insights. So let's jump into foundational principles. What we're going to do here is we're going to spend a lot of time around a particular field in the packet capture that is involved with security, right? So when our management frames, we're going to be taking a look at management frames. Those can be beacons, probe requests, authentication, transactions. We're going to look at all of those, a lot of those in the packet capture. But yeah, we're going to be concentrating on the RSN field. Now, just kind of starting this off right now, we're going to show you the basic connection flow of a Wi-Fi connection. And first of all, discovery process, right? You have an AP that is beaconing its SSIDs and its capabilities. You've got clients running, doing active scanning, which involves a probe request, and then the AP would respond. So that's all about the kind of discovery of what's out there. And then it goes through an authentication process, right? And then association, and then a four-way handshake. Okay, now four-way handshake is going to be prominent in what we talk about today. And then after the four-way handshake, that's when the 802.11 connection is established. But kind of think of it as those are kind of the steps that occur through this. Now, let's talk about keys, right? So keys are what are actually being used, right? When it comes to actually connecting to your network. And you might have seen a pyramid like this out there floating around, but really what we need to concentrate on is kind of the hierarchy here, right? So at the highest level, there is a key called the master key, okay? Now, MSK, it's also is really kind of equivalent, and we'll kind of go through that here in the next slide on what that is. But the point here with the pyramid is we start with an MSK, we start with the master key after that, and then we go into the temporal keys. And as you notice, there's a four-way handshake in there. So it's not till we get to completing the four-way handshake do we actually have the temporal keys. Let's kind of go through each one of those. So the master session key is really equivalent to the AAA key. Okay, and so what this is, it's really more of at the highest level. Now, I'm going to borrow an analogy that Devin Aiken, CWNE #1, threw out there in a paper that I actually have linked in our resources to kind of talk about these different levels. And what he kind of analogy he used was around chickens. And the master key is a chicken farmer. The PMK, the GMK are chickens, and the chickens actually produce the PTK and the GTK. And so those are divided up in that way. Now, the MSK is really prominent when it comes to the enterprise space. It's not as prominent when we talk about the personal space, and we will talk about that. PMK, that is the top level master key for unicast traffic. GMK is the master key for unicast broadcast. And then the eggs that they lay, for lack of a better term, the transient key is used for unicast traffic, and the transient key is used for multicast. Now, the key here is both of those transient keys are generated after the four-way handshake. All right, we're going to kind of talk about a four-way handshake here a little bit. The whole thing I want you to kind of see in this particular slide is the PMK. The PMK is really, I don't want to say key because that'd be, pun intended, but the PMK is where things start, right? And so there's various ways the PMK is generated, depending on if it's personal or if it's enterprise. But the PMK is where we start in the four-way handshake. So we take that PMK and then we start deriving the transient keys from the PMK. All right. So along with that is kind of the authorization and key management indicators. Now, this is a field that is going to show up in the RSN field, okay? And this chart is really more for reference. So there are different types of authorization and key management fields here. We'll be breaking down a lot of these, okay? So, but you can see that, every type of authentication suite has its own value in that field. So the robust security network information element is what we'll be looking at when we talk about the packet captures. Okay, and that is where all the data is that's being advertised, again, through beacons, through probe responses, through authentication responses. That's where this data is going to be shown there. All right, so WPA2 in review. I'm throwing in a very quick screenshot of a beacon in regards to what we'll be looking at, but in an open network, that RSN field is not even present in the packet capture. So you'll see as we jump into the packet capture down here after the power constraint, you'll see an RSN tag in that packet capture. In an open network, there is no security, right? You're just going through the authentication association process and you are connecting. Thus, there is no RSN field that we will see in the packet capture. Let's talk about WPA2 WPA2 in general. So there's a personal mode and an enterprise mode. Now, really what I want to show you in this particular slide is why we have some issues with WPA2. And it is all around the PMK. The PMK, again, is that master key, but in a personal network, how is that derived? When you go into a WPA2 environment, what are we entering in? We're entering a passphrase, right? So we put the passphrase in. From that, there is a PSK generated from the passphrase. They're not the same thing, all right? But it's very limited in what's being used to derive that PSK. And then it's derived as a PMK. The key thing here is once this PMK is established in a WPA2 network based on the passphrase, it is static at that point. And that's why you can have the ability to eavesdrop on the PMK. You can actually run dictionary attacks, just repeatedly trying to guess what the PMK is by entering in passphrases, just one after the other, right? You can do this offline as well. Again, this PMK stays this way, right? And that is the security issue with PMK from that standpoint. Once you get the PMK, then you go through the four-way handshake. You do that in both modes, personal and enterprise, and that's how you generate the PTK. The PTK is session specific, right? So the four-way handshake is user or device specific and session specific, but the PMK is not. So that's kind of the issue there. There's WPA2 personal. We also have WPA2 enterprise. So enterprise does up the ante in regards to security, even in WPA2 mode. But really, what we want to show here is recommendations is removing WPA2. If that is not an option for you, then the only way you can upgrade your security in regards to WPA2 personal is by having a longer password. And I've seen recommendations from 20 to 60. It's a 64 byte field, but 20 plus characters is the only way you can upgrade that. And then if you have to have WPA2, segregate those clients, right? We're going to talk about WPA3. Really the best practices in our minds is to segregate WPA2 clients and WPA3 clients. All right, I'm not going to spend a lot of time on this particular slide, but this kind of shows you how the WPA2 PSK can be cracked, and that is by using again, as to kind of describe the password dictionary, just kind of rotating through these until I can get a match on the PMK, and I can do this offline. That's invisible to the network managers, to your staff as they do that, and they can just hop back in later on once they get that PMK in place and start doing various different types of hacking techniques, where there's just straight up eavesdropping, man in the middle, evil twin attacks, those type of things. On the enterprise side for WPA2, so what that does is now we have that master key, we have a radius server, and it is generating a unique PMK for each user for each session. So now that's the difference here, right? So for the personal side, your PMK remains fairly, pretty much static for the most part. On the enterprise side, that is unique going forward. So that is on the enterprise side. Here's a quick flow. Again, this is going to be more for a reference, but when we talk about the enterprise piece, we have the normal discovery process, and then we have an EAT process that's engaged here. And we'll look at a packet capture here in just a bit. And really the goal here on the EAT process is to get a PMK ready to go for the four-way handshake. So again, PMK is really a key that I would be concentrating on here. So the EAT process here is essentially, and we will see this in a PCAP as well. So I'm leaving this for reference also here. But there is a transaction that is occurring at the EAT level, all to generate a PMK. All right, let's look at a PCAP for just regular old WPA2. All right, a couple things to look at here. So I am now highlighting a WPA2 beacon. And within this beacon, we can see we go down to the particular RSN information. Now in this slide deck, you'll see screenshots of this, but what I want to show you here is this is where you go, right? You go into the RSN information. Within here, you're going to be able to see what the cipher suite that is being used for WPA2. It is AES CCM for both the group cipher, again, broadcast multicast, and for unicast on the pairwise side, you're also seeing the same encryption here. So that's the WPA2 encryption. But the key here is the key management fields. Okay, and so what we're showing here is that this particular client has two keys, and those two keys are, in this case, is PSK, and in this case, and this is what you could argue, this is probably not a well configured SSID. This is fast transition also being enabled on this PSK network. So AKM of 2 and an AKM of 4. So we have two different AKMs in place in this environment. If this was just WPA2, there'd just be one. This is where we're kind of going in to look at some of these things, right? Is where do we see and how we identify what security is being enabled at this particular spot. Okay, let's jump back to our slide here. And that is the packet capture as seen. So WPA3 was brought into play. WPA3, as you notice, I put a date here, 2018. So it has been out there for a long while. And why all of a sudden we're spending a little more time on WPA3? Well, we've got other technologies that are pushing it to the forefront. And those are Wi-Fi 6E, right? So Wi-Fi Alliance has basically mandated that WPA3 and WPA3 only is to be used in 6 gigahertz band. So now we've got to try to address this, or are we going to ignore the 6 gigahertz band because we're really concerned about interop issued by deploying WPA3. So that is why there's a big emphasis here. Going forward, Wi-Fi 7, WPA3 in all bands. So now we can't ignore WPA3, right? So key items of why this session probably is a good time to be talking about this. WPA3 has various modes. In particular, the personal side of WPA3. We have a WPA3 personal only mode. We have a transition mode. Throw eggs at the screen. We don't necessarily like transition mode. There's a new mode just introduced. I think it was in 3.4 version of the WPA3 Alliance document. Personal compatibility mode. So it's another way to kind of try to figure out how to allow clients to connect properly on WPA3 networks. And then there's one that's as of late, we won't talk about it much, but there is a WPA3 personal SAE PK network, which uses a public key to access the network. So new features. Some of these are WPA3 specific. Some of them are actually been around a while as well, but now they're a part of also requirements in 6 gigahertz and Wi-Fi 7. Those are protected management frames. The SAE authentication for personal networks is now in play. Enhanced open, which utilizes opportunistic wireless encryption for open networks. That is now a requirement in 6 gig and on Wi-Fi 7. We've also added 192-bit encryption. For the enterprise side, requires certificates, but it is for those high security type areas, healthcare, government, defense, those type of things. 2020 is when, just kind of pointing this out, 2020 is when the Wi-Fi Alliance started certifying clients. So we've now in play here for 5 years that clients that have been certified in the last 5 years should support WPA3. Protected management frames. Nice reference slide point here is we are now going to encrypt deauthentication, disassociation frames, action frames with PMF. This is one of those things. So one of the ways that hackers get into, understanding what's going on around the PMK and the passphrase on WPA2 is what do? They actually initiate a deauthentication attack, and they deauth clients. They wait for the clients to reconnect. They start looking at the 4-way handshake and to try to understand the passphrase and the PMK, right? So now we're going to address that by actually encrypting those frames. Simultaneous authentication of equals. This is a handshake. It negotiates the PMK. So now when we talked about WPA2 PMK, it was pretty static. It was based off passphrase and a few more variables. Now this handshake negotiates it every time, right? So that's kind of the key here. Knowledge of that password. If you know the password, doesn't matter. It's not going to be able to decrypt the encrypted frames. If your password is very simple, it's going to negotiate through that handshake and make it to where it's a lot more secure from that standpoint. It does that by using what's called an elliptical curve Diffie-Hellman encryption technique. I actually have a link to an explanation of what that looks like. But the point is, it's a technique that is very easy for devices to encrypt, but near impossible to decrypt. Okay. And again, resistance to offline dictionary attacks. So what does a PCAP of WPA3 look like? Let's jump in here and take a look at that. I'm going to show you this particular RSN information. From this particular beacon, we've jumped into the RSN information field. We have a suite count of 1. And this particular key is that SAE. So it's key number 8. So a single AKM, this is WPA3 only, as we see here. Now, we talked about protection management frames. Where do we see that in the packet capture? That's going to be under the RSN capabilities. Here's the management frame protection required, and the management frame protection capable. Those are both designated as 1. So those are enabled for SAE 3. Okay, so that's how you would determine from the beacons what type of encryption we're looking at here in regards to SAE. All right, that's WPA3 only. That's the highlighted version of what we just saw. Here is a transaction regarding SAE. So one thing that's interesting about this piece is there are 4 different authentication frames being utilized. So at the top, we see probe request, probe response, and then we get into authentication. The first 2 authentications are using a commit. So they're actually handling this handshake. So now they're negotiating, what the different PMK is going to look like as we go through this. So commit 1 goes from essentially client to AP, and commit 2 goes the opposite direction. Then they confirm it on these other 2 authentication frames. And then from there, they jump into the 4-way handshake. We're kind of off and running at that point. All right, transition mode. So what happens when we do transition mode? Well, essentially what we're doing is we're adding AKMs to that RSM information field. Now, why is this a problem? Many clients have a problem with having more than 1 AKM in that RSM field. Clients, as we know, clients can be, especially older clients, they can struggle with that. We saw that in previous situations where just a single additional AKM means client didn't even connect. They didn't even understand the field at all. And so you might see that come in. So that's the risk when we start introducing transition mode. But the goal here is, of course, let's allow WPA2 clients connect as always, and add the additional WPA3 support so WPA3 clients can connect as well. Again, I think one thing that we recommend here is let's update WPA2 client drivers for those particular clients. So maybe they won't disconnect, but ultimately the best practice that we're going to bring in is the fact that we ought to not even utilize this transition mode at all. So transition mode, I'm not going to jump into the packet capture itself. You kind of see where that is, but here is a screenshot of what that would look like. So in this case, we got a transition mode of PSK2 and SHA 256 SAE. So this is transition mode would look like in the beacon packet capture. And notice protected management frames, management frame protection. This is the IEEE definition. So that's why it looks a little inverted from what you would see as far as what Wi-Fi Alliance has. But now we're just in a capable mode. So we're not requiring management frame protection with that particular beacon. That was just 2 AKMs. Can you have 3 AKMs? Absolutely. So in this case, this is an example of having 3 different AKMs. We got a suite count of 3. We have 2, 8, and 9 involved. So in this case, we got PSK, just WPA2. We have SAE, and now we've also initiated fast transition on top of SAE. And again, we're just setting the management frame protection to capable only. Multi-BSSID. So this is kind of interesting here as well. So when we start talking about 6 gigahertz, they have this possibility of using multiple BSSIDs in a beacon. Why? Well, it saves on management traffic, right? So now I can actually advertise multiple SSIDs within a single beacon. I think I'm going to go ahead and grab this one out of a packet capture here. So here's an example of what we would see with that is we're going to see 1 AKM at the highest level for a particular SSID. But then we might see down here under multiple BSSID field, additional non-transmitted BSSIDs. For example, in this case, you look up here in the top right, if you can see that okay. The main SSID is EPOD 6 gigahertz, but the ones that are non-transmitted are the EPOD MLO. We can see that down here as well. Okay, so what we can see with this particular packet capture is there's something called inheritance. So there is not a separate RSN down here under this MLO particular SSID. So it just inherits SAE only from the top level up here. Okay, but again, we can get kind of complicated in here what we see around what AKMs are involved here. All right, WPA3 compatibility mode. All right, so this is a little different, right? So this is new. So compatibility mode is going to allow for a WPA2 and WPA3 support. But what it does is it limits that AKM field to just one entry. Okay, so it's not going to allow you to put in three different AKMs there. Why? The intent is to not to confuse those clients that have problems with multiple AKMs. So transition mode, multiple AKMs, compatibility mode, a single AKM, but then it populates a separate field called an RSN override field and an RSN override field 2. And so within those override fields, that's where it might advertise a different AKM. All right, so the goal here was to not have WPA2 clients not able to connect at all by limiting that field, but also providing WPA3 clients to connect. Now, the risk with that is, do we have WPA3 clients that look at those fields? Right, it's a new field that's out there, not readily deployed. So will the client be able to recognize that field? And again, recommendation here will be to update WPA3 clients. So here's a packet capture of what that looks like. So there is an RSN information field up top, but now you've got a Wi-Fi Alliance vendor-specific RSN element override and override 2 fields that are now populated down below. And then down below, that's where you will see where it adds in these other AKMs. In this case, left-hand side, you're seeing SAE being added to this particular field, and then also SAE, the higher encryption cipher being utilized with an SAE of 24. All right, so WPA3 enterprise mode. So really the add-on here over WPA2 enterprise is we're adding those protective management frames. That's really the difference. And this upgrade is really, it's been seen as transparent to the user, right? We do have the added AKM capability of 192 as we saw, but the point here is that WPA2 enterprise is pretty much, WPA3 enterprise is pretty much WPA2 with PMF added. So if you're running WPA2 enterprise, go ahead and move to WPA3. It really shouldn't be a huge issue there. Enterprise mode, again, we have enterprise WPA3 enterprise mode only. We have a transition mode as well. And then we have 192. PCAP for enterprise only. You're going to get that one suite count in the RSN field. It's going to be AKM 5. Again, make note, we now have management frame protection and is required as well. Here's a quick look at a connection flow here. Okay, so we got initially we have the beacon, then we have the probe response, probe request. We negotiate authentication. We go ahead and associate, and at that point, we are going to initiate EAP. And we're going to go through there and we're going to do, request identity. We're going to respond to the identity. We're going to, each side, whether it's the supplicant and the server, they're going to validate each other's certs, right? So this will be certificate paste. And then from that, they're going to, at the very end here, right, have the successful negotiation. They'll have a PMK to hand over to the four-way handshake to generate those PTKs. So a PCAP of transition mode, WPA1, WPA5. or excuse me, WP, yeah. So AKM1 and AKM5 we're seeing here in the RSN information. Again, transition mode, management frame protection is not required. Enhanced open. So let's up the ante in regards to security for open networks. Let's use opportunistic wireless encryption. This really changes privacy, but not necessarily security. No change in user behavior. That's probably a debate there, but that's the intent, that the user behavior, they don't have to log in. They don't have to do any additional steps here beyond what they might already have in place, which could be a captive portal, right? But sessions are encrypted. That's kind of the main difference between this and a straight open network, is that the session itself is encrypted with a Diffie-Hellman. It does prevent eavesdropping on that open connection. The risk, and I think this risk has been proven out to be a large risk, is that legacy clients are having a hard time connecting to OWE. And many times we have vendors, right, that are now also have OWE transition mode enabled, trying to resolve that connectivity issue. I think that may have actually created a worse situation in many cases. But again, to try to address this, update the drivers as best we can. An enhanced open PCAP, here's what the beacon looks like. There is a separate AKM. It is AKM 18. Notice management frame protection is required on an enhanced open network. If you want to see what this looks like from a connection flow perspective, here is a screenshot of that flow. One thing of interest is, how do I know that OWE is in place? You can look at the authentication request, and you can see that there is a separate tag in the PCAP that will designate OWE Diffie-Hellman parameter. Wi-Fi 7, additional items in here, right? So WPA3 is being required across all bands. GCMP 256 ciphers is going to be required. I say it's going to be required. I've got a Wi-Fi 7 consumer device that still is advertising 128, not 256. So again, probably trying to avoid phone calls, right, of customers calling in saying, my clients can't connect. That's kind of what basically that. So the cipher is being added, AKM 24 is being added to support Wi-Fi 7. But again, these are going to be seen across all bands. So it's not just a Wi-Fi 6 band, or excuse me, a 6 gig band of concern. So that's WPA3, WPA4, quantum computing. I'm sure you probably have heard of it, but it's coming. Really, it's going to be a game changer around quantum computing. So I'm not going to be able to go into all the details on quantum computing. But point being is, once that comes out, WPA3 will be rendered pretty much useless. Quantum computers will be able to break it. So there'll be need a post quantum computing standard brought into play. And we're speculating it's going to be called WPA4. How can Wyebot help? So a couple things to notice here. We do have the sensors as we mentioned earlier. First off, you can get historical PCAPs, right? So we can't really, that's kind of the foundational pillar of what our technology does, is that we're always running packet captures. You can go back, depending on how this sensor is configured, you can go back up to 2 weeks to go grab historical PCAPs. So having that ability to always have PCAPs readily available and to be able to go back in time is key for that. The other thing we can do is we can actually automatically identify what AKMs are out there, right? So we kind of talked about and looked at packet captures, but you know what? Our system can actually identify those for you and bring those to light. The other thing we can do is we can actually run synthetic tests. We can actually configure our client that's on the sensor to emulate any of these AKMs, essentially. So you kind of see a screenshot here. If we identify, so if you put in your network, your SSID into our dashboard, we'll automatically look at what the AKMs are and show those to you within our dashboard. But the other thing you can do is you can actually manually create a profile, and you can select any of these particular AKMs, the ciphers, and also whether you want to have PMF show up as required, capable, or neither. So those are some of the things we can do from our perspective. And of course, we can connect as, like I said, as a WPA3 client. We can run a variety of synthetic tests emulating that WPA3. So here's kind of a slide of how we see that, right? So there is your kind of your reference points of where we're going, looking into the packet capture ourselves, analyzing it for you, so you don't have to use Wireshark, and bringing that to light within our dashboard. All right, so summary of best practices. So what we'd like to talk about here is just use WPA3, right, where we can. Understand home networks. You enable WPA3 only. In my case, at my house, I had 16 clients connected to a WPA3, WPA2 transition mode. SSID, I moved that to WPA3 only. I dropped 6 of my clients, right? So those clients older than 2020, right? Maybe I can update some drivers, but that's something, we need to look at. But know your clients, right? Know what you have out there. And then testing, right? We just need a test and we need to test again, right? So as you bring in new clients into your infrastructure, make this a part of your policy. Let's just make sure, update those drivers, make sure that we can actually connect to WPA3. If WPA2 is something that you have to have out there, again, segregate those out, right? Have an SSID, VLAN as WPA3 only clients, and have one for WPA2 as well. If you want to use transition mode, I look at that as a means to an end. In other words, it goes back up to this test and test again mode, right? Let's not set it and forget it. And I think that's probably what's going on with a lot of customers, right? They just kind of say, you know what, I want to introduce WPA3, but I don't want the hassle of trying to figure out what's going on with older clients. So I'm just going to set for transition mode and leave it as that. And I would encourage us to not do that. Let's use that as almost a testing phase to get to know what our clients' capabilities are. Versus transition mode, we talked about compatibility mode. You could check that out as well if you want to kind of observe and see how that looks in your environment. All right.
Brad, thank you. That was deep. That was what we committed to, the deep dive, and yeah, very educational. So thank you so much. I just wanted to show the slide to anybody watching today. We do have an offer for a free Wi-Fi analysis, free trial of the sensor. If you haven't tried out our tech yet, you're welcome to go to this website and just fill out the form. We would schedule just a quick demo to overview what Wyebot is, what it does, understand your environment, what you're facing, and if a sensor trial or an agent trial could make sense. The trials are pretty simple, pretty straightforward. There's no contracts, no paperwork. We just ship you a sensor, you plug it in, and yeah, see the insights that you get from the Wi-Fi sensor there. So just let's see, I put a link in the chat here to that too. You can just go there and fill that out if you're interested. With that, though, we'll go to the Q&A. So we had a few still in the queue that we didn't get to on the back end. But Jacob, do you want to kind of kick this off with some of the questions we've seen?
Yeah, no, absolutely. And Brad, thank you very much for putting this together. I mean, like Mike said, I mean this I did my CWSP last year, and I was like, my head was spinning, with all these things, the four-way handshake, the PMK, the PTK, the block cipher. I mean, it's a lot of info, right? And what I like about this session is it's really hard, I found, to find all this type of info in one place, right? So Brad, yeah, really appreciate you putting all that effort in. So we have a couple, good questions here, right? Sally, you asked an excellent one that I wanted to talk about live, right? Um, he had asked Salo, what do we really think about these transition mechanisms, right? We've talked about why we probably shouldn't be using them, WPA2/WPA3, OWE transition. There's compatibility mode, which maybe is a more elegant way to handle these things. I'll give my take on it, and then Brad, maybe if you want to give yours. I guess I would say, right, what I don't like about transition modes is sort of why I also don't like many temporary solutions, right? Because the temporary solution is pretty much permanent, as we all know, right? If transition mode works, why are you going to change it 5 years from now when there's really no need for it? We see this today right? I mean, when you look at we see a lot of networks that people are still running TKIP, right? WPA1/WPA2. Why? Well, maybe they needed to 8 years ago, 10 years ago, whatever it is, but it's still there, right? So, you know, in my opinion, right, when you're really setting up your network and you want it to behave in a certain way, like it's probably better just to say, we're WPA3 only. It's very well supported. Yes, some versions of it are better, more supported than others. Like, WPA3 Enterprise is a good example. That's pretty much just supported. Any modern client that can do WPA2 Enterprise can do WPA3. And if they can't, update the driver. And then if you need the WPA2, well, making a separate SSID for that, it's not the end of the world, right? Just keep that around for the time being. But, you really should, from just forward looking, and we talk about quantum computing, all this stuff. I mean, 10 years down the road, I mean, these things are going to be more real, right? So that's why I don't like transition modes, just because you're kind of putting a band-aid on something, right? It's better to go all the way. It's not, not easier said than done, obviously, from our perspective, but that's just my opinion when I look at a lot of networks that have been around for a while and how things stay configured. So, Brad, I don't know if you have anything to
No,
add there.
you summarize that very well. Absolutely.
Fair enough. Yeah, Brad, you've spoken enough today. Let's get some
That's
water
right.
or something.
I'm recovering.
Yeah, Anders. Yeah, so a couple things. So yes, yeah, we'll be going to WLPC. There'll be certainly I'll be there. I think Mike, are you going? Maybe, hopefully. Um, we'll
Yeah,
see
plan
who
on
else
it.
we can go. Maybe Brad, I'll see if I can get you to come as well. I know Adam, our counterpart's going to be there with me. So, but yes, we'll have more of a presence than we have had in previous years at that conference because it's an excellent one to attend. What else? Wi-Fi 7 sensor in the works. The answer is yes to that. We are working on a Wi-Fi 7 sensor, so stay tuned there. What else? So Manny, you asked if you get better security if you use .1x auth for even for WPA2. Absolutely you do, right? I mean, it's a best practice to use WPA2 Enterprise if you're in an enterprise. It's harder to set up, obviously. There's more things to maintain. You have to deal with the radius server, but as Brad had pointed out, right, WPA2 personal, I can't consider that to be truly secured if you really care about people being able to decrypt your over-the-air traffic or break into your network. And even WPA3 personal, you can't decrypt it anymore, but if somebody figures out your password, they can get on your network. So yeah, I mean, I would recommend using .1x wherever you can. I mean, it's hard to set up, but it's worth it if security is a priority for you. All right. Let me read. This is a good question. I just got to read the whole thing. Yeah, okay, so good question. Mr. Anonymous attendee. So the question here is like, how are we gonna take an inventory of our drivers and know what needs to be updated? Um, well, conveniently, if you are a Wyebot customer or you want to learn about our DEX agent, one of the things the DEX agent does is it will report on the driver version, and you can see the breakdown of the different driver versions clients have, the different bands and SSIDs they connect to, and all that stuff. So that's one way to do it. Obviously, if you wanted me to give the Wyebot answer. Otherwise, I'm sure there's other if you have like management of all your devices through something like Intune. There's probably a way to see drivers. In general, right? Windows doesn't do an amazing job of making sure your drivers are updated all the time. So, like, just check, right? Like once a quarter, I don't know, make it a task and go through and see if you have a lot of like really old drivers out there and get those up to date. Yeah. Rasika always does amazing sessions. So anything you can find from him, watch those for sure. Uh, bu- 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 Yes, yeah. There's a lot of stuff, right, where you can't upgrade, you can't replace things. That's just the nature of the beast, right? Again, best practice there is probably to use segregated SSIDs to support those devices, unfortunately. Yes, Mac OS agent is coming. Wow, a lot of questions. This is great, but I'm trying to keep up here.
I told you I might generate more questions than answers.
Yeah, Brad, come on.
No?
You should have explained every possible question during the webinar. Uh, let's see, is 802.11r supported in all the transition compatibility modes? Yes, yeah, 802.11r is supported. 802.11r is a gigantic topic that we didn't really get into today, but it is supported. If you want my 2 cents on 802.11r, I'm a big fan of it for enterprise authentication. I don't think you should bother with 802.11r if you're using personal pre-shared key. Reasoning, you're saving time on the four-way handshake. We just had a long conversation about this morning. You're saving the four-way handshake, right? Which, what is that? 10 milliseconds, 20 milliseconds, for all the added complexity with 802.11r. It's definitely worthwhile though if you're running enterprise authentication, because your radius auth can take 500 milliseconds, 1 second, whatever it is, and that will affect real-time communication. So you should use it. Just tread carefully and make sure you don't misconfigure it. It's kind of easy to do depending on how many knobs your vendor gives you. Let's see what. Okay, what is the roaming performance between? Okay, this is a good question. So roaming performance between WPA3 personal versus WPA2 personal. Very similar, honestly. Like they both work well because they're fairly simple. It's all, all the negotiation and stuff is between the client and the AP. So there's not a lot to go wrong. So yeah, pretty much similar. I mean, there are, of course, under the hood differences between WPA3 and WPA2, primarily regarding the, if you really look at it, you'll find the WPA3 uses a different auth protocol. So like an auth type. So normally it's open system auth, which is just a two-way, AP client, whatever. WPA3 SAE uses a 4-frame, it's like a commit confirm. So the Diffie-Hellman, I might be wrong about this to be honest, but I believe the Diffie-Hellman exchange happens during the auth exchange.
Correct.
Is that right? All right. Brad knows more than I do, so he just dove into this like head first. So Brad, you better go take your CWSP exam after this. I feel like you get an honorary credential. Let's see. Upgrading to Wi-Fi 7 in the near future. Would that be an opportunity to jump to WPA3? Yes, absolutely. If you're upgrading APs and you're redoing stuff anyway, I like the scream test for a lot of this stuff, right? Like just turn on WPA3. If stuff doesn't work, you need to seriously think about if that device needs to be upgraded or if that device needs to be on my secured enterprise network, whatever it is, right? So yeah, absolutely. There's no better time, I think, to rip these band-aids off than when you're doing a full infrastructure, change. Oh, don't say that, Martin. Why do they keep updating these exams? We should still be being tested on like TKIP, as far as I'm concerned. And if you passed your CWNE 20 years ago, that's enough. No, I know actually. I'm doing the CWISA right now, and like I need to finish it by December because the exam's changing. So thanks for reminding me. 256-bit keys. That's a good question. I believe, Brad, maybe you know. So 256-bit keys with WPA3 Enterprise. Yeah. Do you need 192-bit for that, or is there a?
You do.
Do you? Okay. Good to know. Yeah, that stuff gets very confusing because it's called 192-bit, and there's like SHA-384. so like all these key lengths confuse me. But yes, 192-bit is needed there. Awesome. All right. Well, I think we're approaching time. Any other last minute questions? Get them in quickly. Appreciate everybody joining and learning with us.
Love it. No, thanks, Jacob. Thanks, Brad. Thanks, everybody, for joining.
Yeah.
When the webinar closes out, a survey is going to pop up. Just 2 questions on the quality of the webinar and then any topics you'd like us to cover in the future. So please do answer that for us. We'll keep the topics coming. So have a good rest of the day, everybody. Thanks again to Brad for your prep, and we'll be seeing you.
Thank you.
Yeah, great job, Brad. Appreciate it. Thanks, everybody.